I'd like to welcome everyone to this webinar with Ascend Elements. I'm Nancy Schultz. I'm on the board for Sustainable Newton. Happy Earth Day to everyone who's here. It's a beautiful day here in Newton County, and it's a great day for Earth Day. I'd like to introduce Maurice Carter, who is also from Sustainable Newton. And our guest today is Roger Lynn from Ascend Elements. And Ascend is a new business that has decided to locate here in Newton County that is actually going to occupy one of our existing industries, so that they are setting the stage for sustainability. So I'm going to go ahead and turn it over to Maurice, who will be moderating today, and to Roger. Welcome, Roger.
Thank you, Nancy. Pleasure to be here.
Okay, well, good morning, folks. And so a lot of you knew this already, but back on January 5th, Governor Kemp announced that a Westborough, Massachusetts-based startup, at that time called Battery Resources, was going to open North America's largest lithium-ion battery recycling facility in Covington. It was a $47 million investment with 150 jobs, and that's a big deal economically for us. But for those of us, groups like ours in the sustainability space, it's an even bigger deal for climate action and for our planet's future. Some of you may have seen the story we shared last week on CNBC, talking with the CEO of Ascend Elements and telling the story of why this is so important. We look at it this way, you know, EVs are critical to meeting government goals for carbon reduction, for meeting industry commitments to move aggressively towards electrifying transportation. So it's a big deal, and yet batteries are sort of the long pole in the tent, if you will. It's the Achilles heel of electrification, in that managing that supply chain, having the materials to make the batteries, to power the vehicles, is a challenge, and also environmentally mining those materials and what we do with those batteries at end of life is also significant. And along with that, not just in the transportation space, but all over, industries are having to shift to from a linear economy where we take materials, we make something and we throw them away, to a circular one where we keep resources in the supply chain, and at end of life we bring those valuable materials back to make new products. And so our guest again, Roger Lynn, is the Vice President of Marketing and Government Relations for Ascend Elements. They became Ascend Elements in January after the announcement here, and he'll tell us, I'm sure, what that means and why that term is so important. But Roger joined the company in 2021 with 20 years experience in the lithium-ion battery industry. He also serves on the board of the U.S. Energy Storage Association. He has an MS in Engineering Materials Science from MIT, a BS in Ceramic Engineering from Rutgers, and is an inventor on 10 patents. On top of that, he's a really nice guy who's taking time out from the stressful job of getting this Covington facility up and running to spend time with us this morning to talk about who is Ascend Elements, what is their proprietary recycling process, what are their plans in Covington, and what does this mean for the industry and the world. And the theme for Earth Day this year is invest in our planet. We can't think of a better example locally than what Ascend is doing here. And so, Roger, as I turn it over to you, I want to thank you for the investment that your company is making in the planet and in our community. And we've got the Q&A here in Zoom. So as Roger goes through, if you have questions, go ahead and type them in. Some we may hold till the end, but some, if they're sort of relevant to the topic at the time, Nancy's going to watch that for us, and we'll ask your questions for you. So with that, Roger, I'm going to turn it over to you. And again, thanks for being with us.
Yeah, that's great. Thank you, Maurice. Thank you, Nancy, for inviting me to speak here today. I'm really happy to be here. And obviously, we're thrilled to be a new addition to the Covington family down there in Georgia. I just had the opportunity to be down there last week, and it's a beautiful area, and we're really happy with the progress we're making, all the support we're getting from the community. So that's great. What I'd like to do is give you guys a little bit of background on what it is we're doing out there as a company, for the EV industry, the lithium-ion battery industry at large, more about our company and what our mission is, what our goals are, and really give you a flavor of why it's so important today. So again, my name is Roger Lynn. I'm the Vice President of Marketing and Government Relations here at Ascend Elements. Our mission really is a very sustainable mission. It's really to elevate the value of recycled elements by engineering sustainable materials for the global transition to clean energy. And really, in a nutshell, what we're after is to achieve sustainability without compromise. And I'll go into a little bit more about what that really means. But we rebranded our company from our old name which was Battery Resourcers to Ascend Elements back in January, essentially to embody our mission in our name, right? To take these elements, especially for lithium-ion batteries, elements are like lithium, obviously, nickel and cobalt and others, but increase their value by material science and engineering and return them back into the battery supply chain to make the entire battery supply chain and the EV battery supply chain more sustainable. And so it really fits in with the theme of what we're trying to do and with what Newton County is trying to do. So we talked a little bit about our old name and how we changed our name before, but as a bit of background, we're not really new at this. We've been doing this for quite a long time. In fact, we've been the technology leader in looking at the recycling of lithium-ion battery materials. Back in 2012, the initial developments and the initial patents were developed at Worcester Polytechnic Institute, or WPI, here in Massachusetts. And in fact, this is where our headquarters is, in Massachusetts. And it started early on when our founders looked at the lithium-ion battery industry. And again, I've spent nearly 20 years in this industry. Recycling was never a big concern up until recently. But our founders had the foresight to look into this 10 years ago and start developing innovative technologies, really unique technologies, purpose-built for the lithium-ion battery industry at a time when people weren't really focusing on it. So we have a very unique perspective and a long history in the space. What we do is recycling lithium-ion batteries and scrap using our patented process to convert them to what we call cathode active materials, or CAM. And the cathode active material is really the most important material in the lithium-ion battery. It defines the type of lithium-ion battery it is. So, those of you that know the industry know that there are different kinds of lithium-ion batteries. Some are called LCO, some are called NMC, some are called NCA or LFP. These are all acronyms for the type of materials used in the cathode active material. And it's really the heart of the lithium-ion battery, and also responsible for nearly half of the cost of the lithium-ion battery. So it's very, very, very important. Our unique hydro-to-cathode technology provides sustainable, low cost and low embedded CO2 cathode active materials back into the battery industry using recycled batteries as feedstock. And so what we're really after is closing the loop, making it truly circular, in the sense that we can make it sustainable and help to offset things like new mines, or avoid disposal of used batteries in landfill, which obviously has a lot of concerns around it. We're in scale-up mode now, with all the interest and all the increased funding that we've been able to secure over the last year. We're expanding our capacity. Our first commercial facility is in Covington. We'll be processing 30,000 tons of spent lithium-ion batteries per year when it's operational later this year. And globally, we're expanding as well. The EV market is expanding, not just here in the US, but over in the EU and the UK and in Asia. So we'll be looking to expand to 150,000 tons of input lithium-ion batteries processing capacity per year by 2026 in all those locations. So in a nutshell, what do we do? I did say that we are a recycler, a battery recycler. And on its face, that's kind of what people see us as. We're a lithium-ion battery recycler, but it's not just recycling. We're actually transforming these spent lithium-ion batteries. And you can see a picture here of our warehouse area in Covington that's taking incoming battery scrap from one of our suppliers, using our hydro-to-cathode process and transforming them directly into new custom high-performance active materials. And you can see basically in this jar, this glass jar on the top right, what that active material, a cathode active material, a CAM material looks like. It's really just a black powder. It's pretty nondescript. It's not very interesting to look at. But again, this black powder is the most valuable component in a lithium-ion battery. And we're elevating the value of those recycled elements to the highest point in the lithium-ion battery supply chain, which is this cathode material, in this case NMC, as I'm showing here. So we talked a little bit about what we've achieved recently. This is a snapshot of some of the things that we've done. Obviously, we talked about the Covington facility. When it's operational with 30,000 tons of processing capacity per year, it will be the largest battery recycling plant of its type in North America when it's operational later this year. We need it to be big, and it's in fact maybe not even big enough. There's a lot of battery scrap that's going to be generated, that will be created over the next decade, and we'll need to create quite a bit of capacity in addition to the one in Covington to accommodate it all. We do have commercial traction. We're working with a lot of automakers. Honda is one of our partners, where we're recycling all their lithium-ion batteries from their EVs in North America. We've got contracts and agreements with other large automakers. Those many of you've heard of, but we can't disclose. But they're all feeding our recycling plant. We're also working with lithium-ion battery manufacturers themselves. You guys may know there's a very large gigafactory in Commerce, Georgia, that's producing lithium-ion batteries installed by SK Battery America. We do have an agreement with them to process their manufacturing scrap. And we're also now selling our cathode material coming out of our hydro-to-cathode process. And our first sale was with a military and DoD defense contractor called Navitas Systems up in the Michigan area, where they're providing our materials into mission-critical DoD military applications. And so we've made a lot of progress, and we're not stopping there. We're going to continue to expand, obviously, and I'll talk a little bit more about that later. Let's take a step back. Why is recycling lithium-ion so interesting now? And it's a question I asked myself when I joined the company back in October of last year. And so it turns out the materials that are required for manufacturing lithium-ion batteries are in scarce supply, and they're getting more expensive. You can see some of the headlines here. Lithium hits ludicrous mode as the battery metal extends at 400% gain. This is back in January. In fact, since then, lithium has continued to increase in price, and we feel that it will continue to increase as the demand goes up. And again, the demand is driven by EVs and the gigafactories that make the batteries to power those EVs. Now, those gigafactories all need to be fed lots of critical minerals, critical metals, battery materials. And so in addition to lithium, we're looking at sources of cobalt, we're looking at sources of nickel, graphite or carbon as well. They're all very, very important to operation of lithium-ion batteries, and they're just becoming more in high demand. So supply chain issues are really beginning to hamper, and we may start to see, after lithium-ion battery prices have decreased for the last almost 2 decades, we may see our first year in which they increase again because of some of the supply-demand imbalances in the supply chain. So most of the batteries that we make will be, or that we recycle, will be coming from a couple different applications. And so on the left-hand side, you'll see just a breakdown of where all the lithium-ion batteries manufactured are going. Today, a lot of them are going into passenger vehicles, over 60%, just because they're just so large and so much bigger than anything else we use lithium-ion batteries for. And again, over the next decade, it will continue to dominate the application segment, followed closely by commercial vehicles. So this is not just passenger vehicles or light duty, but trucks and buses, et cetera. And then everything else is sort of that top green bar. In total, this is about 3,000 gigawatt hours worth of demand globally by the end of the decade. And I've seen estimates recently that have almost doubled this. And so as we continue to look at where batteries are going to go, we know that we're going to be making a whole lot more of them in the coming decade, over a tenfold increase than what we do today. And so what are we going to do with those batteries? They don't last forever. They all need to be handled at end of life and disposed of properly or recycled. And so that's where we come in. We're looking at taking that lithium-ion battery material, whether it's end-of-life batteries that have reached the end of the useful lives, or for manufacturing scrap, and using that as feedstock for us to then return back into the supply chain. On the right, you can see the breakdown of how many batteries are going to be coming to us from both end-of-life and from manufacturing scrap. Today, most of it will be manufacturing scrap. These gigafactories, as they start up, they do generate quite a bit of scrap as they dial in their processes. It reduces over time. but it will still be in the 6, 8 to 10% of total output. But then over the back half of the decade, we expect that to flip, so that end-of-life batteries coming off of EVs or other applications will begin to become the majority of our feedstock. So in summary, there's just a lot of batteries coming at us, and we need a way to handle them once they reach the end of useful life. And why is that? Well, as I think as Maurice had mentioned before, there are some, let's say, concerns with the supply chain of these critical metals and critical elements for lithium-ion batteries. They do cause a fair amount of environmental damage and social injustice as we extract them from places like Africa or Australia, or even here in the United States, as we look to open more and more open pit mines. And so once they're out, and once we pay that heavy toll for extracting these elements, we ought to spend as much effort as we can to keep them in the supply chain and not let them go into landfill. So there's an economic value, there's an environmental value, and a social value for us to recycle these things. But it's in the headlines, right? There's a lot of detractors to the EVs and the batteries kind of pointing out their flaws. And no doubt there are issues and things that can be improved. And that's one of the things that we Ascend Elements are doing, is to help improve the cleanliness and the environmental impacts of the entire industry. In addition to that, there are, let's say, supply chain security concerns that exist, not just here in the US. I'm just showing a few of the things that the federal government has issued to look at how do we secure the supply chain for batteries in the United States, but even around the world. Every country sees the importance. China saw it long ago. South Korea, Japan, the EU, the UK, they're all now scrambling to secure these critical elements that are used for lithium-ion batteries today. And so having this security supply chain is really important as we move ahead in this global clean energy transition, away from fossil fuel vehicles into electrified vehicles, away from even fossil fuel power plants electricity, as we move into renewable electricity, and have some of that be helped out or supported by very large battery storage systems on the utility grid. The supply chain today is, from a US perspective, very foreign dependent. A lot of the metals that are used in lithium-ion batteries come from places like South America, Africa, Indonesia, Australia, foreign countries. And they're all refined basically in China into battery grade chemicals before they get shipped over to the battery factories, like the one that SK is running in Commerce here in the US, that then go into electric vehicles. And so it's a very tortuous and a very inefficient path for these metals to come out of the ground and then find their way into the EVs or into our devices. And so there must be a way to make this better, make this more efficient. And it's one of the things that we're doing essentially to make that supply chain a lot more efficient. I won't go into detail on this chart. This basically just shows the sources of the raw materials for each of the critical elements: graphite, which is carbon, manganese, nickel, cobalt, lithium, around the world. And you can see very little of it is produced in North America. So essentially, this whole idea of recycling lithium-ion batteries has become hot in the last couple of years. Again, kind of driven by the revolution in electric vehicles, which was, I think, driven by Tesla initially and the success of their electrified vehicle lineup. And then sort of the follow-on with all the major automakers following suit with huge investments in EVs. This has spurred on the installation and development of gigafactories, battery gigafactories around the world, and they are all very hungry. They need to be fed these critical elements. And so, once we get them out of the ground and use them up, we ought to turn them around and get them back into the supply chain as efficiently as possible. And so, as you see here, the world needs to crack battery recycling fast. And it's one of the things that, we as Ascend Elements think we've done that. And we started with the most valuable material, again, taking those elements at the highest value point in the battery supply chain, the cathode active material. And I'll talk a little bit about what we do there. So before I move on, I'll just pause here and see if there are any questions that I can answer. And again, if there are questions, put them in the chat, and we'll we'll look through them. But Nancy, are there any questions that I may be able to answer?
The questions are not really related to the battery, to your presentation. They're more related to issues on housing locally. So I have Sarah Hall with me, and she is answering those questions in the chat. I do see that there's one question that just came up, and it says, does Ascend or has Ascend been able to find the necessary workers for its facility? Appropriate level of training or experience?
Yeah, so we are hiring rapidly in our Covington facility. I'm not as close to the hiring process itself. I know we are bringing on new people all the time. So the talent pool is certainly good here. I think what we'll do is, maybe I can just comment at a high level on that and say that, we're looking for a range of skill sets, from factory warehouse operators all the way up to plant engineer types. We are continuing the interview process as we onboard more people throughout the summer as we become online. But I'm not aware of any high-level issues with finding the talent that we've got now. It seems to be going at a fairly normal clip. And again, I think it's just the wealth of the talent pool in and around the Covington area that has helped us, be successful in that area.
The things that will pop up at the end with the sort of, the post-meeting page that will pop up includes a link to the jobs that Ascend has available currently in the Covington market. So we thought people might be interested in that, both to see the nature of the work and then what's available for some of you.
So Roger, I have two more questions. One is related to the employment. And do you know how many employees you plan to hire at the Covington plant?
It's about 150 employees total for Covington.
All right, great. And then the second question is, what made you decide on Georgia and Covington?
That's great. That's actually a great segue to the next slide I've got. So let me just dive in there. I'm going to talk a little bit about the lithium-ion battery projects in North America. And again, we feed our processes from manufacturing scrap from gigafactories, as well as end-of-life batteries and the EVs that have reached end of life, so the automakers. So this map basically shows, it's a pretty handy and free to access map that these guys at battery-news.de put out, but it shows circles where there are gigafactories going in all around the country, all around North America. And you can see just down here in the southeast area of the country, there is quite a concentration, some very large circles of activity. And one of the reasons we chose the Southeast, one of the reasons we chose Covington, Georgia, is a proximity to these manufacturing facilities. We need access to manufacturing scrap coming out of these gigafactories. We need access to the scrap that may come out of the EV factories. And obviously there is a fair amount of automotive scrap recycling operations in the Southeast, and we will be taking scrap from those guys as well. So essentially, the reason we put it down there is because it seems that everybody else is putting stuff down in the Southeast. There's a very strong automotive presence, obviously, in the Southeast, and that's extending itself to the EV manufacturing sector as well, and all the gigafactories that power those EVs. And so that's one of the primary reasons we decided to site down in Georgia. But in total, all these battery factories here, the sum of all the volume of the area of these circles, which correspond to the size of the gigafactory, essentially, that's somewhere in the order of 800 gigawatt hours of production capacity that'll be online towards the latter half of this decade. And so that's a huge amount of capacity. Just for reference, I think the entire world produced only half of that last year. And so, looking at expansion of just that much in just North America is really tremendous. I never would have expected this kind of volumes in my time in the lithium-ion battery industry in my career to reach this level just for the United States. It is really amazing how this has turned around recently, driven by essentially by the demand and by the automakers. So it's really fabulous to see.
Roger, we have two more questions, actually three more that have popped up. What are the byproducts of battery recycling?
Yeah, there's a lot of byproducts, and we sell those byproducts to specialty recyclers if we don't handle them directly and turn them into battery materials. Some of those are, for instance, when we go and shred a battery, we create a few different byproduct streams. The one that we're most concerned with, the one that's most important to us, is called black mass. And that black mass really contains that cathode active material, anode active material, the nickel, the lithium, the cobalt, the graphite, the carbon, et cetera, in it. And we kind of reserve that for our use and turn it back into new material after breaking it down into the constituent elements and into the atoms of each of those compounds as materials. But we're also creating off streams or byproduct streams of copper. There's a lot of copper used in lithium-ion batteries, of aluminum. There's a lot of aluminum foil used in lithium-ion batteries and of plastics. And so those are some of the byproducts we create and then ship off to specialty copper, aluminum, or plastics recyclers. On the backside of the process, we're also, producing some specialty chemicals we'll sell to commodities brokers that get sold off into other industries. And so in total, we're recovering something like 98% of the mass of that battery and returning it either as, specialty battery materials or engineered battery materials, or as byproducts that get sold into the commodity markets. And so we're working really hard to make sure that we get as much out as we can. Again, one of the basic tenets of recycling is if it's not economic, it probably ends up going to landfill. And so as we extract every last bit out of the batteries we can, we're increasing the value of that scrap lithium-ion battery, and hopefully in that way promoting nearly 100% recycling rate for lithium-ion batteries.
I believe that your answer answered both questions.
So I'm just showing the stadium here just to give you guys a sense for how much 800 gigawatt hours of batteries would be. This would be if you could stack them up with no space in between perfectly. It would fill it to the roof. AT&T Stadium in Texas is the largest, dome stadium in the United States. I was going to put on Mercedes-Benz Stadium, but I couldn't figure out what the volume was. So if somebody happens to know what that is in cubic meters or cubic feet, let me know, and I'll let you know how many of those the batteries will fill up.
Fill that one too, I'm sure.
Absolutely. So it's a lot of batteries that are coming at us and need to be processed. And this just gives you a sense for how many, and this would be produced every year once all those gigafactories on the previous slide are up and running and producing what they are stating. So I'll go a little bit into the technology. I won't dwell too much on this because I think it gets a bit esoteric and into the weeds. But again, our process, which we call hydro-to-cathode, is really the most efficient way to recycle a lithium-ion battery, the most efficient way to return it back into a very highly engineered battery active material. Again, the heart of the battery, the lithium-ion battery itself, compared to all the other methods out there. And so I'll just do a quick recycling process technology comparison here. There are a few different ways to recycle lithium-ion batteries, the oldest of which is called pyrometallurgy. This is a method by which, as you could guess by the name, you burn the batteries and you melt them down. And then from there, you extract things like cobalt, nickel, and lithium, and then return them back to other folks who then have to make the precursor or the cathode, and then turn those materials around and then sell them to the battery manufacturers themselves. And so that, that distance, that path from point A of spent battery to point B of new battery is pretty long and inefficient. It's in fact the least efficient method to recycle lithium-ion batteries today. A newer method is based off of hydrometallurgy, and it doesn't use any high temperatures or incorporate any incineration, and so it is a lot cleaner and a lot more efficient than traditional pyrometallurgy is. But at the same time, you're still creating byproducts like cobalt salts, nickel salts, lithium salts, or the commodity metals that really aren't combined together yet into this highly engineered material, which we call cathode active material. It still has to get produced, separated out individually as an intermediate compound, and then sold off to somebody that makes a precursor, who then sells it to somebody that makes a cathode, who then sells it once again to a battery manufacturer like an SK battery, for instance. So it is still a relatively inefficient path. It's better than pyro, but traditional hydro still leaves much to be desired. And so we developed at Ascend Elements something called hydro-to-cathode. It's the world's most efficient way to turn those spent lithium-ion batteries back into usable battery active materials. And you can see is a lot shorter and goes directly into precursor synthesis and cathode production. So that's all within our single process. So we'll take those spent batteries, put them in our process, and spit out at the other end something that the battery manufacturer can use directly. So to use an analogy, it's sort of like the direct nonstop flight to get from point A to point B, where all the other methods out there are like taking connections, 2, 3, or even 4 connections to get to your destination. It takes longer, it's a longer distance involved, it uses more energy, it's creates more emissions, etc. But our process, our hydro-to-cathode process, is the nonstop direct flight back into the battery, into the gigafactory.
It's probably a good time because one of the questions in the chat was about emissions, and I had been asked in the past also by people, like not just emissions, but energy usage. So maybe you could talk about how this process, how that is different in terms of emissions and energy usage also.
Yeah, absolutely. So actually there's a slide on this coming up, so I'll address it there. But again, just to hammer the point home, the idea is, we're taking those spent batteries and turning them into this far right bar, this engineered active material. And this chart basically just visualizes the value per ton of spent batteries. So if we're shredding off the batteries and we get the black mass off the bottom, the value of that is, for instance, 1. If we do a traditional hydro process or a traditional pyro process and create lithium, cobalt, or nickel commodity metal salts using a technique called solvent extraction, the value is about 3. But if you take it all the way back to the cathode active material, these engineered active materials, then the value per ton is 10. And again, if you improve the economics of the recycling process, you will drive more recycling. And again, this is what everybody wants, is to prevent any of these from getting to landfill and getting them all back into the front end of the supply chain to make it truly circular.
I think, Roger, one of the other concerns that's mentioned in the chat is that, we've had other industries in Newton County that have posed concern for emissions for citizens. And does your process, are there any emissions that are going to be of concern for air quality, water quality, anything that citizens would be fearful of?
Yeah, so this slide I'm showing here just summarizes some of the environmental impact of the process itself. What we're looking at here is comparing, in fact, emissions, CO2 emissions, greenhouse gas emissions, from a kilogram of cathode produced using our process versus that produced using a traditional process. And so, if we look at that environmental impact, it's much reduced, over 90% reduced emissions versus traditionally made cathode active material. The code name for that here is NMC 622, but it's a very, very impressive reduction in emissions when you take into account the offsets from the mining, as well as the renewable energy that we could be using to process the materials. In addition, SOx, NOx, particulate matter, and water consumption are all lower than the traditional production methods are. And so there's just a strong, let's say, benefit in using recycled content, using recycled material for the battery itself to reduce its overall environmental impact, and then reduce the EV's environmental impact as well.
So the next question actually speaks to the water, how much water is used, and you have answered that it's 47% lower, but if you have anything to add to that, to answer that question a little bit more specifically regarding the water usage, I think that would be helpful.
Yeah, no, that's good. So we do a lot of reclamation of the processed water, and everything that we'll be using within the plant, we're going to be reusing in a more of a closed loop method, and recovering it so that we can continue to circulate it through the process itself. Any water that is discharged from the plant will be treated and will meet all the local and the state environmental guidelines and stay well under the threshold of any materials that could be harmful to the environment. That's it. Our philosophy is to not just make the battery cleaner, but to make the recycling process itself cleaner as well. So people have talked a lot about recycled materials being inferior to those that are made brand new, from brand new feedstock, and we've worked hard to try and dispel that myth, and really get the point across that we can achieve sustainability without compromises on performance, for example. And so what we found with the cathode materials that we produce is that the performance, it rivals and in some cases exceeds that of materials made traditionally, from newly mined and virgin materials. And they exceeded in two cases. One is in power capability on the left. And I won't explain the chart, but it just means that you can charge and discharge it at a faster rate and get better performance. And then on the right, it shows the durability or cycle life performance, and that they will have a longer cycle life than those created from traditional materials. Now, this is an artifact of some of the engineering capabilities we have in our hydrodecathode process. It essentially is able to engineer particle and material properties that are advantageous to performance. So we can alter things like the porosity, the particle size, the distribution, the shape of the particles, et cetera, to the customer requirements and engineer it to what they need. We can also change the composition. So if the composition from batteries that are made 10 years ago isn't relevant today, we can go in and actually modify the composition so we don't have to actually use the same chemistry that was used 10 years ago. We can update it and make it more future-proof. Okay, so I'll move into recycling challenges a little bit, just to talk about a few of these things that we're concerned about. Obviously, the upfront is still very important. Collection, sorting, identification of those batteries has an impact on what we can do with it and what the value ultimately will be. And so there's a universal method to collect, sort, and identify what's in the batteries that's going to be hugely important to us. Also, dismantling, disassembling is important. If we can do this more safely, there are a lot of ways to take batteries apart, and not all of them are safe. And so we want to ensure safety for all our scrap yards out there and the dismantlers, as well as our folks, to make sure that we know how to take apart an EV battery when we get one. They don't always come with disassembly instructions, and sometimes we'll have to fend for ourselves. But fortunately, we figured out ways to make them safer so that they don't end up misbehaving during the disassembly process. But I've exhorted all the EV battery manufacturers, designers, et cetera, from the manufacturing battery manufacturing companies, as well as automotive OEMs, to consider end-of-life disassembly in your upfront design. That will reduce the cost of processing and will actually make that scrap less costly to process and be a benefit to whoever's disposing of it. It's important to know what's in it, how much lithium, cobalt, nickel, copper, graphite, et cetera, is in it, so we can readily assess what the value could be after it goes through our process. And then there's still concerns about transportation. Moving batteries around is expensive. They require special packaging. If they're damaged, it could cause other issues in the transportation process, on the truck or the train as they're being moved around. And so we have to consider how best to do this and reduce the cost to do this at the same time. Recycling site permitting, industry regulatory issues continue to be moving around as more and more people take notice of how important this part of the supply chain is, and closing the loop for lithium-ion batteries. So certainly a lot of challenges still ahead of us, but we're making good progress in improving the overall process. Okay, so I'll just finish up with a couple of shots of what we're doing to scale up. This is a shot of our Covington, Georgia facility. You guys may have seen this. We actually occupy the building in the back. It's an older facility. We are recycling in a way to repurpose it for processing lithium-ion batteries. We'll be shredding scrap batteries and manufacturing scrap from gigafactories into that black mass, extracting lithium, nickel, and cobalt from this. This is sort of the first phase of our operations. It really isn't our cathode production facility. That we are going to be opening up a separate facility, again, somewhere in the Southeast, which we call an Apex class facility. And this facility, Apex 1, will be taking the outputs of the base facility in Covington and transforming it into the highest value materials using our hydrocathode technology. So we hope to get that sited and located shortly and up and running hopefully sometime in 2023. So so that's it for the for the prepared slides. So again, we're trying to achieve improved recycling economics to drive 100% battery recycling rate, keep everything out of landfill and get it all back into the supply chain. That will reduce our reliance on mining of lithium, of nickel, of cobalt, whether it's overseas in foreign countries or here in the US, and then achieve a truly circular battery economy, completely closed loop manufacturing. So with that, I'll close, and then we can go into more open Q&A and answer specific questions that we haven't addressed yet.
Roger, your presentation was excellent, and I think that all of us that are on this chat, on this presentation, would love to have a copy in some way. I know that we will be, we recorded this, and people can go back and look at it at a later point in time. But it, you know, I think it's just so much information that it's very exciting to see. I'm going to go ahead and. We have had a flurry of questions, so I'm going to go ahead and start posing some of those for you. Do you plan to return recycled material back to the original OEM cell manufacturer that you received scrap from? If not, why not?
Yeah, so it doesn't necessarily have to go back to the same person that created it. It could. But I think one of the beauties of the process that's flexible, and so we can take in batteries from one manufacturer through the process, modified, engineered along the way, and then create something that's suitable for somebody else. And so we like that flexibility. We like the idea that we can custom engineer and custom tailor the materials for different applications, even if we're using feedstock that wasn't from that original application. So it doesn't have to, but it could.
Is there an uptick for other companies to do what you are doing? And if so, what will keep you a viable entity for Covington?
Yeah, so I think there's going to be a lot of activity and people reaching further into sort of the, I've been describing what we do as grave to cradle, in a sense, taking stuff that it's at end of life and returning it back to the beginning of life. In fact, we go a little bit further than that. We're going, grave to elementary school, let's say. So because of the efficiency of that process and the increased scope of how much of the supply chain we are serving, and the efficiency of that, I think we'll see more people start to get into it. Obviously, innovation is key. There's still a lot of challenges in how we process these things, what the costs are, what the challenges are, some limitations on capabilities. As we continue to innovate to process different chemistries, obviously chemistries will change over time, make those processes more efficient. We'll stay ahead of the competition there. But we're looking for innovation in chemistry, in hydrometallurgy, in material science and engineering, in battery engineering as well. And we're looking to, again, extract as much as we can out of these spent elements and then raise them up to the highest level as possible. So innovation is key to stay ahead, and we think we've got the right team to do that.
So that's a great segue to our next question, and that is, other types of lithium batteries, are you going to be able to recycle the lithium from smaller devices such as phones and power tools?
Yes, so we are actually doing that today. One of the reasons we focus on EVs is, again, if you think back to that chart I showed about where it's coming from and where it's going, most of the batteries, most of the volume is coming from EVs, again, because these batteries are just so enormous. But the process can handle your iPhones, your Android phones, your tablets, your iPads, laptop computers, hoverboards, whatever it is using lithium-ion battery. That process is agnostic to the type of battery going in. So again, in Covington, we'll have the very large shredders that basically chew up the batteries into tiny little bits. The shredder basically eats all types of batteries, and the black mass that comes out, because we can go in and adjust the composition and change the ratio of the nickel, the manganese, and cobalt. We can update and change the composition on the fly. So even though we have mixed streams coming in, we can adjust the solution, adjust the soup, so to speak, to taste, and then make something that is fitting the requirements on the output side.
And there's that's a good follow-up question to this is, if homeowners or individuals have small devices that have lithium batteries, will you have a place where they can recycle those batteries locally?
Yeah, so right now we're working with people that do sort of the collection and the sorting operations. There's some great outfits out there that do this already. As many of you probably already know, you can recycle any type of battery through drop boxes at hardware stores and other locations. These are actually a lot of them are put in place by a nonprofit organization called a Recycle. They've been batteries for years.
And we're actually trying to set up a session with them soon too, to also give a more consumer-oriented angle on what we do with these things. So.
Yeah, precisely. And so, we'll be taking batteries from different sources, the collection, aggregation, sorting of these things. While we could be doing that, our focus again is to take those materials and process them and increase their value, right? Add value to those materials, and then get them from the end of the life cycle back into the beginning. And we're partnering with people to do collection, sorting, et cetera, of the scrap batteries. If it's from a large operation, let's say the gigafactory, we obviously will go direct because of the aggregation of volumes there. But for the small ones, there are people that do a better job of that than we do.
Will you make the finished cells or just the cathode material?
Yes, that's a good question. So yeah, people do think that we make batteries. We don't make batteries. We do make the battery materials that go into the factories that make the batteries.
And what is the supply chain for your EOL batteries?
So EOL batteries will come from a number of different places. Some will come directly from the automakers that are creating scrap. Some of them will be coming from some of the aggregators we talked about. Some of them will be coming from large scrap yards that take in EV batteries as they get into accidents or just are otherwise scrapping the vehicles themselves. And so they come from a number of different sources.
At this point, I have one more question coming through. They're typing it. So
and I had one.
Go ahead, Maurice.
I just wanted to, Roger, I want this one kind of draw on your whole 20+ years experience in the industry. But, in the sustainability space, I've become a keen observer of the battery industry, not a very technical one, but certainly appreciate all the developments taking place. But one of the things I've noticed is a lot of young, bright people who seem to have grown up with a sustainability mindset. And so what I see is a lot of collaboration. I mean, there's competition, you want competitive advantage, but it seems like everybody's helping each other solve this problem. So one, do you agree with that collaborative sense? It seems different than maybe the oil industry 50 years ago or the plastics industry 30 years ago. Do you agree with that observation, number one? And number two, are you hopeful that the industry will be able to solve the challenges ahead?
Yeah, so I think people are really beginning to understand the magnitude of this recycling and processing infrastructure that's needed. Obviously, even with Covington in place, with the 30,000 tons of processing capability, it's not enough going forward. And so we obviously encourage and applaud all the other companies that are doing work in this space to help reclaim them. I mean, first and foremost, we have to avoid these things going into landfill. Consumer electronic devices use quite small lithium-ion batteries, but lithium-ion batteries, if abused or mishandled, they like to misbehave. They like to start fires. And so, in fact, if you dispose of a consumer electronics device with a lithium-ion battery improperly into general waste stream, a lot of these will end up causing fires, downstream in these waste management facilities. And so, it is actually a really big challenge. And so, first and foremost, I think we want to build up the industry in such a way that we can avoid that from happening. Let's make that path from end of life device or EV battery or just battery in general to make it back into the hands of a recycler, of a processor, to make that inevitable, right? And so that's one of the things that we're on a mission to do, is to prevent anything from going to landfill, first and foremost, to forestall any safety hazards or issues there. Secondly, lithium-ion batteries can contain some materials that wouldn't be good. For instance, cobalt is not good to be leaked into the environment. It is a heavy metal. Nickel also has its concerns as a contaminant. But fortunately, those things have value. And this is one of the ways that, we're trying to do two things at once, is prevent those from polluting and contaminating environments, but at the same time, reclaim the economic value of it and return it back into the supply chain. And then also offset any mining of new material. For every kilogram of cobalt we recover, it's one less kilogram of cobalt one needs to mine in the future. And that's going to be beneficial for everybody as well. But yeah, I do see a lot of collaboration. There needs to be a lot of collaboration to work together to, again, every gigafactory that gets built for all the gigawatt hours of batteries being produced, there needs to be a matching infrastructure, a matching giga recycler to process it at end of life.
Thanks.
And that collaboration goes to one of these questions here about what kind of relationship do you envision with fire departments, because the lithium batteries are a fire hazard?
Yeah, so we work closely with fire departments to make sure that we're operating within, all the parameters and all the permitting, all the requirements. We set up our facilities in a way that satisfies any of the fire safety requirements from, NFPA 1, et cetera. The lithium-ion batteries themselves, once they are, through our process, our upfront process of discharging and dismantling and shredding, they are rendered into a very, very safe condition. They are no longer a lithium-ion battery after that. It is basically constituent components. It's, scrap metal foils, copper, aluminum, plastic bits, and this black mass, which is essentially inert once it goes through the front end of the process. But I'm very well versed in the safety of lithium-ion batteries. I've actually served on several safety standards committees, for lithium-ion batteries for use in stationary applications, like large battery arrays for solar farms, for instance, in aircraft and transportation applications, as well as just general, battery safety standards. So we're following, the best practices out there to prevent any accidents from happening as we take in these spent batteries.
Some other questions relating to collaborations. Are you collaborating with the University of Georgia or Georgia Tech? And if not, who would be your best person for those universities to collaborate with you?
Yeah, so I'm actually going to be over in Athens at the University of Georgia next Friday at the Mobility Summit out there. I'm not aware of any, let's say, technical or R&D type projects that we have with the universities locally. I'll have to check in with some of our teams that we see we've got any activities going on there. But it's a great idea. I mean, it's a great talent pool. It's a great, engineering population in and around Atlanta. And so, we'll take advantage of it. Obviously, in hiring, first and foremost, getting these talented chemical engineers and other folks into our ranks. But there could be opportunities for collaboration outside of that as well.
I would mention many of our followers and supporters know we've done a number of projects with the folks at Georgia Tech and the Ray C. Anderson Center for Sustainable Business. So we did hook Roger and Tom Fry, who's communications lead for Ascend, up with with David Eady, who many of you know, at the center down there. And so we're hoping that that Ascend Elements can be a great resource, and the center a great resource for them to collaborate as they get settled in and actually get their transition behind them.
So we have another question related to, we have a great career academy. We have STEM education here. And for our young students who are interested in your company, what ways do you envision that students can plug in locally?
That's a good question. I think there's a lot of opportunities just to learn about the industry at large. Starting with the battery itself, where it's going to go, how it works essentially, and what happens when it gets disposed of, and then how the circular economy can help. So I think there's a lot of things that can be done just from an education standpoint to get people talking about it. Fortunately, a lot of this stuff is being reported on. I found more often in the news than in years past, and so there's more of it reaching sort of the conventional wisdom of the general population than there ever has been. And so it's not as it's not as much of a niche as it was, when I got started in batteries many years ago.
So just to wrap up a little bit, we have had several questions towards the end here about how we can access information on employment, individual contacts with you. I know that there's going to be a slide at the end of the presentation. I just want to thank you again and thank all of the participants. I think it's really important to note that Newton County we have a fantastic industrial and development authority who has been working with different industries to bring in these new technologies. We're on the forefront here in Newton County. We have our water authority has worked very diligently on a water first program. So your company being here, we are so grateful to you that you made a decision to come here. It fits into our mission for the future and our vision for the future. So we're really excited to have you. And I know that this won't be our last conversation with you. So be prepared.
Thank you, Nancy.
And at this point, I'll turn it back over to Maurice if you want to. I guess you've already put up that slide. Is that correct?
Yeah, it should be on everybody's desktop, but we'll make sure that, we'll have the recording of this out probably later today if you want to share it with folks. And we've included links to more info on the hydro to cathode process, which fascinates me, even though I'm not technical enough to understand it, but I can understand the value. We've included links to where to follow news about Ascend Elements as they go through their journey here, and also jobs for those that are interested, and also links to our calendar for upcoming events, a place to join us if you want to join us, and our currently members. So Roger, I know as you said at the opening, this is a very busy time for you, and not only you're not just showing up talking to us, you're being asked to appear all over the place, and but that makes us feel special that you took time out for us, and we can't wait to see things grow here.
No, thank you. Thank you so much for
taking time. And like Nancy said, thank you everybody who joined us this morning. So we'll do more of these. And again, happy Earth Day.
Yeah.
I think you guys see now why we thought this was a good topic for Earth Day. So I think we'll wrap it up then, and we'll be in touch. Thank you, everybody.
All right. Bye.
Bye.